Okay, for today's session, we will be focusing on mixed strategy game. We'll also see dominance theory, a principle of dominance to solve the games as well, especially related to the mixed strategy games. Now, what do you mean by mixed strategy game? Now, if you remember, last time we had solved the pure strategy game by finding the saddle point. So it is a very simple statement I can make regarding the mixed strategy games. If we are not able to find, or if we do not get a saddle point, that is, maximum is not equal to minimax, it is a case of a mixed strategy game. Here, the player can, play the strategies in a proportion or in some probability. So they are actually not playing one particular strategy. They are playing a mixture of two or three different strategies in a particular proportion, okay, such that they either make optimum gain or they have to have the optimum strategy. In case of loss, it will be optimum loss, okay, or you can say minimum loss compared to the profit which the other person is making. And as we know, the profit of one player is the loss of the other player. Okay, that will give me the value of the game as well. Now let us see some definition here. Now, as I have already told you, when for a given game we do not get a saddle point, it is a case of a mixed strategy game. Now, in this, the player mixes the different strategies with certain probabilities or proportions to be found out. We will be solving the problem by finding this probability values so as to optimize the expected payoff. Now, we use the algebraic method to find the solution of a 2 by 2 game with mixed strategies. And especially when we are solving this problem using the algebraic method, please remember, we need to have a 2 by 2 game only. If the dimension is different, then we need to go ahead and use the principle of dominance and reduce my matrix or your payoff matrix to a 2 by 2 game and then solve it further. Now, there are some formulas which we should know. If this is my matrix given, where there are two players, A and B, with two strategies each, that is A1 and A2. Let us say A1 has the player A plays the strategy A1 and the proportion or the probability is P. Then the probability of playing the strategy or using the strategy A2 is given by 1 minus P. Okay. Similarly, for the player B, if Q is the probability with which he's using the strategy B1, then B2 will have 1 by 1 minus Q probability. Okay. And the main purpose of solving this whole game, first of all, especially in case of your mixed strategy game, is to find out the values of P and Q. And similarly, we can use these values and go ahead and find out the value of 1 minus P and 1 minus Q. Okay. Now, what is P here? P is the probability that A uses which strategy? A1. And 1 minus P is the probability that A uses strategy A2. Similarly for B1, for Q and 1 minus Q. Now, let us see the steps first. Now, let us say P is the probability that A uses strategy A1. 1 minus P is the probability that A uses strategy A2. Similarly for Q, Q will be the probability that B uses strategy B1, and 1 minus Q is the probability that B uses strategy B2. The second step is for player A, P and 1 minus P should be such that we should have same payoffs irrespective of B using B1 or B2. Okay. Thus, we can say that, the expected payoff to A when B uses, say, B1, is equal to the expected payoff of A when B uses B2. So in both the cases, whether B is using B1 or B2, it should be equal to the expected payoff to A. Okay. Now this formula, the formula which we'll be using to get the value, this can be written as this way. We can write A11, if you refer to this previous matrix which we had, payoff, this is your payoff, multiplied by the probability P plus A21 into bracket 1 minus P equal to A12 into P plus A22 into bracket 1 minus P. Okay, and solving this further, we get the function for finding the value of P as A22 minus A21 divided by A11 plus A22 minus A21 minus A12. Now, to make it very easy for you, whenever we are finding the value of P, look at the values of the last row, you can, or the second row, okay, because we have only two values. The last value, that is A22 minus the first value of the last column, last row. Okay, that is how you have to work out. So A22 minus A21, whereas the denominator is cross multiplication. You can see, use the cross values. So for the first diagonal, just 1 minute, please. Just hold on. Okay, sorry for the interruption, but there was a call. Okay, fine. Going ahead, let us see the next formula for finding out the value of Q. Now, if I get the value of P, then finding out 1 minus P is very easy. So the main formulas are given for P and Q. Okay. The next step would be to get the value of Q. And as I said, expected P of to B when A uses A1 is equal to expected P of to B when A uses A2. So we are talking the reverse way. So the payoff of B should not change irrespective of what A is using, whether he's using A1 or he's using A2. Okay. This can be written as this here. Formula will be Q equal to, again, look at the last column values, but this time we are going to refer not to the row, the last row, but the last column, because we are talking about the player B. So it is A22 minus A12, and the denominator remains the same, that is A11 plus A22 minus A21 minus A12. Okay, this values can be used further to find out the next value of 1 minus Q, which will hence be the optimal strategy for B as well. Okay, so finding the value of P and 1 minus P will give me the optimum strategy for A, and finding the value of Q and 1 minus Q will give me the optimal strategy for the player B. Okay, now how do I find out the value of the game? Once we get the values here, we can find out the next value, the value of the game. And the value of the game is equal to the expected payoff to A when B uses B1 multiplied by the probability that B uses B1 plus expected payoff to A when B uses B2 multiplied by probability that B uses B2. Okay. Now, when we are talking about the value of the game, this value of the game is for A. Okay, please remember, this value of the game is for A. And that is why we are talking about the expected payoff to A. So now the probability that B uses B1 is Q, and the probability that B uses B2 is 1 minus Q. So if I represent this in the formula and solve it further, I get the value of V equal to A11 multiplied by A22. So it is cross multiplication, you can see. So minus A21 into A12. Okay, so cross multiplication of the payoffs and this, you can say subtraction of these two values divided by A11 multiplied by, plus A12, 22 minus A21 and minus A12. Now this denominator remains the same throughout, whether we are finding out the value of P, Q or V. Okay. And so what you can do is find out the value of this denominator. Okay. So the denominator can be considered as, let us say, a D. Okay. Usually it is represented by D. You can find out this value and then use it to do the calculation for the values of P, Q and V. Okay. You can, if in short, if you want to remember this, one more thing, please remember this last statement is very important. The value of the game for B will be minus V. Okay, so whatever value we get for A, that is the value of V, the same value, the negative value will be the value of the game for B. Any doubts till now? Okay, let us see one more thing, especially if you want to remember the formulas. You have to find, as I said, the value of D is equal to A11 plus A22. So the first value and the last value in my 2 by 2 matrix minus A21 minus A12. Okay. This will give me the value of D. Now, property of using the first row A1 or the strategy A1 can be written as second row difference starting with A22. Now, the second row is the last row, you can say, because we need to have 2 by 2 matrix. So A22 minus A21 divided by D. This will give me the value for P. Similarly, for Q, it is second column and not row now. Second column difference starting with A22. So A22 minus A12 divided by D. That is going to give me the value for Q. And we can find out the value of the game as difference of the cross product of diagonal elements. Okay, so it is A11 multiplied by A22 minus A21 into A12 divided by D. Okay, so basically we are going to make use of this formulas, and it will be more easy if you remember this. It will be more easy for you to remember the formulas. Let us take an example. The question is find the value of the game and the optimal actions for the players. Now we have been given a matrix, a very simple matrix. We have two, you can say, players A and B, and we have got the values or the payoffs as 11-7 for A1 strategy. For A2 strategy, we have 9 and 10. And let us, first of all, whenever we get a problem like this, the first thing is to find out whether we have a saddle point. Okay. If it is not available, the saddle point is not there, then we go ahead and solve the problem using the algebraic formulas. Okay. Now, if you have to find the saddle point, what is the step? You have to find the maximum. So first of all, find the row minima. So in this case, what is the row minima? For the first row, 7, and for the second row, 9. What about the column? In column, we have to find column maxima. So 11 and 10. Now, these values can be used to find the maximum. So in case of the rows, 9 will be the maximum of the minimum. And in case of the column maxima, we have to find out the minimax. Okay. So if we find the value of the minimax, okay, what is the value? We have 11 and 10. The minimum is 10. So 10 is not equal to 9. So it is a mixed strategy game. Because we do not have a saddle point, we can go ahead and solve this further. Now, this is how we got this answer. So first step, remember, whether it is a mixed strategy or a pure strategy, always, first of all, try to find out the saddle point. If we do not get the saddle point, only then we can go ahead and use the algebraic functions, which we just saw, to find the values of P and 1 minus P. And because we already have a 2 by 2 matrix, okay, we will directly jump into the calculations. Let us do the calculation. So using the algebraic method, first of all, we'll find out the value of D. So D is equal to your 11 plus 10 minus 9 minus 7, which gives you 5. Okay. Now finding the probability of the player A using action A1. Now we have to look at the last value. So the last value is your 10. Okay. So 10 minus 9 divided by D. Okay. So when we do that, we get 1 by 5. Okay. That is 20%. And once we get the value of P, the value for 1 minus P will be 4 by 5. Okay. So that is nothing but your 80% probability. Or probability we can say 0.8 and P is 0.2. Okay. Now to find the value for Q, now we have to consider the second column, the last column, which will be 10 minus 7. So 10 minus 7 divided by 5, that will give me 3 by 5, which is nothing but 60% or 0.6 probability. And 1 minus Q will give me 2 by 5, that is 40% or 0.4 probability. Okay. The last value which we are going to find out is the value of V, the value of the game for A. Now do the cross multiplication and the difference between these values. So 11 into 10 minus 9 into 7, that gives you 47 divided by D, that is 5. And the overall value is coming to 9.4. Okay, so the value of the game for A is 9.4 and the value of the game for B will be minus 9.4. Okay, and thus we can write the optimal strategy for A will be 1 by 5 and 4 by 5. And for B will be 3 by 5 by and 2 by 5. Whereas the maximum gain for A is 9.4 because the value of the game for A is 9.4. That is nothing but the maximum gain for A. So we can write here the last statement. The optimal actions for A or the strategy for A would be in the probability 1 by 5. So if he'll be playing 20% of the time, he'll be playing the first strategy, and 80% of the time he'll be playing the second strategy. Clear? Any doubts while solving this mixed strategy? You can put it in the chat or you can ask me any questions before we go ahead and solve for a few more problems. Anyone? Okay, there's no doubt. Very good. Let us go ahead and see if by chance, if suppose they give you a problem where it is not a 2 by 2 matrix or 2 by 2 game. Okay, we have more rows and more columns. Might be either the rows are more or the columns are more. So the strategies are not 2 by 2 or the matrix is not 2 by 2. Now in that case, we have to make use of the principle of dominance. Okay, what is the principle of dominance here? Let us say we have a particular, let us say example of A. Okay, because when we consider the first player, we are going to talk about the profits which that particular you can say players are making, right? So the intention would be to increase the profit of the player A. Now in that case, what happens is if suppose there is a strategy which is compared to the other strategy, it is going to give me less profits or payoffs. Then instead of considering that particular strategy, we can ignore that strategy or neglect that particular strategy. Okay, so the principle of dominance actually states that if a strategy of a player dominates over the other strategy or another strategy, okay, in all the conditions. That means all the values should be dominated. Okay, then in that case, we can ignore the strategy which is being dominated. Okay, the opposite will go for B. Now, in the case of A, what we are going to try is we are going to compare all the payoffs of a particular strategy with the payoffs of the other strategy. If all the payoffs of, let us say, A1 is greater than all the strategies of A2, right? Then which one I should neglect? I should neglect A2, because A1 is dominating all the strategies or the payoffs of the other strategy A2. So we need not consider that. Now, this principle is applicable only if you have not got a 2 by 2 matrix. Okay. You can make use of the principle of dominance for all the types of strategies, whether it is a pure strategy or a mixed strategy. If the question says that use or apply the principle of dominance, then you can go ahead and apply the principle of dominance till we get a single value. Now, I'll get a single value in case of pure strategy. Okay, that will be nothing but my saddle point. Whereas in case of a mixed strategy, I won't be able to get a single point, but I should convert my matrix into a 2 by 2 matrix, so that using the algebraic functions, I can go ahead and do the calculations and find out the values of P's and Q's and the value of the game. Okay, that is overall, you can say, briefing regarding the principle of dominance. Let us see what we have here. So the principle of dominance states that if a strategy of a player dominates over another strategy in all conditions, that is for all counter strategies by the other player, then the later strategy that is being dominated can be ignored. Okay. A strategy dominates over the other strategy only if it is preferable over the other under all conditions. Okay, that is a simple, you can say, statement. It makes sense. It will make sense when we actually do the solve the problems. Okay. Now, if you have converted, if suppose you are able to convert the matrix into a 2 by 2 matrix, then we can go ahead and make use of the algebraic method. Now, there can be condition where that you are not able to convert this matrix into a 2 by 2 matrix. Then in that case, if suppose it is a 2 by n or m by 2 matrix, then there are different methods which are used, especially graphical methods are used to solve the problems, say, of size, say, 3 by 3 and more. And it can also be solved using linear programming technique. Now, both these techniques are not part of the syllabus, especially in case of your game theory. Okay, so we are not going to look at the problems where after reducing also we are not able to get a 2 by 2 matrix. Okay, so remember this, that whatever problems you're going to get, you will be able to convert the matrix into 2 by 2, especially because we are not covering any other problems. Now, what are the different techniques or the steps which are used to actually convert your payoff matrix into a 2 by 2 matrix using the principle of dominance? Okay, let us see the steps first. Now, what are the steps involved? So if suppose you have a m by n problem, okay, first of all, you need to check out whether we have a saddle point. Okay, if there is a saddle point present, then we need not go ahead and solve the problem using the principle of dominance, because it won't be required. But remember, if in the exams they have asked you to solve the problem using the dominance principle of dominance, then please make use of the principle of dominance. If they have not mentioned it, then check whether you have a saddle point. If you do not have a saddle point and it is not a 2 by 2 matrix, then you have to go ahead and use the principle of dominance to solve the problem. Okay, so first thing, check if there is a saddle point. If a saddle point is there, then the optimum solution is directly obtained. Okay, this it will be just a game of your, it will be a pure strategy game. Fine, you need not go ahead from this. But if the problem does not have a saddle point and we need to reduce this into a 2 by 2 size, we need to make use of some rules of dominance. Now, what are those rules? These are very important rules. The first few rules are very easy. So if all the elements in a row, okay, say the ith row are less than or equal to, okay, even equal to is considered here, less than or equal to the corresponding elements of any other row, let us say in this case jth row, then neglect the ith row. So the values which are less, we have to ignore it, provided all the values are less or equal. Okay, clear? Why we have to ignore the one which are less? Because we are talking about profit in case of the player A. Okay, so across the rows, we have to consider less than equal to. Now, if all the elements in a column, now when we are talking about the column, if all the elements or if all the values in a column, say the R column, are greater than or equal to corresponding elements of any other column, then neglect the R row, the one which is greater. Okay, it is the opposite. Because when we are talking about the player B or the column values, we are talking about the losses which this player is going to make. So we need to reduce the losses here. Okay, only then it will be the optimum strategy for player B. So in both ways, if we have to increase the profit for the rows for player A, and we have to reduce the loss for player B, that is across the columns. Okay, and that is why this condition. Now, if we have a pure strategy, okay, if a pure strategy may be dominated, it is inferior to the combination of two other strategies in a certain mixed proportion. If suppose we are not able to reduce using the first two rules, that is, if all the elements, that is for the row and the column, we are not able to, neglect any of the rows, then we need to do the combination. Okay, so we need to have combination of two or more, you can say, columns or rows, depending on the condition. Okay, in this case, again, if suppose we have two rows and we are using the fixed proportion k is to 1 minus k, and finding out the sum of the two payoffs, and then we compare it with the other row or the columns. That is how we are supposed to go ahead. Now, this will be very much clear when we actually take a problem and solve it. Okay, the third point is very, you can say, important in this case. And please remember, it is not very easy to find out the value of k and 1 minus k. Finding the value of k and 1 minus k, first of all, finding the value for k and then checking whether it is able to reduce my matrix further is a big task, because there's no you can say rule given to find out the value of k. It is always depending on the person. So you have to try with some values, take some values and try it out. And if it is possible, you might get it in the first go, or it is just trial and error. Okay, if suppose, let us say I take the value for k as 1 by 2. Okay, so 1 minus k will be 1 by 2. So in this case, when we have the combination of two rows, okay, I'll be multiplying that by 1 by 2, right, and finding the resultant values or resultant elements for each column. Okay, and then comparing with the other row. If suppose this is not helping me to reduce any of the rows, then I have to go ahead and check with the value of, say, k equal to, say, 1 by 3. Might be if k is 1 by 3, then 1 minus k will be 2 by 3. Again, use this proportion, do the calculation, check whether I can reduce or eliminate any particular row or column. If not, then go ahead with the next value, say 1 by 4, and so on. So please remember, it's a lengthy process. You might not get the value of k immediately. If you're lucky enough, 1 by 2 will work, and you might be able to reduce the matrix further. Okay, so this last step, especially the step number 3, is more critical and very important to solve your problem. Whereas the first two steps are easy, and it will just going to help me reduce the matrix immediately. Okay, it's very easy. Just by observation, we can do this first two steps. Now, on getting the last step would be the third step. On getting the reduced payoff matrix of size 2 by 2, we have to use the algebraic method to get the optimum solution. So we are going to find out the value of P and Q, and also the value of 1 minus P and 1 minus Q, followed by the value of the gain V. Okay. Now let us quickly take one simple example. So we have this game here. We have two players, player A and player B. Now player A has 5 strategies, 1, 2, 3, 4, 5 in numeric values. And player B has 6 strategies, Roman numbers, and the payoffs are given to you. Now, as you know, the first step would be to find out the row minima and the column maxima. Find out the value of maximum and the minimax, and check whether we are able to get the value of whether we are able to get the saddle point. Now, please do it and let me know, guys. And as you know, we are taking an example of principle of dominance. Definitely, there won't be any saddle point here, but I want you all to give a try and check it out. So in the first case, row minima will be 0 here, 1 here, -5, -1, -2. Okay. Here the column maxima will be 4, 3, 7, 3 again, 2 and 2. So none of the values I think will be matching with the say row minima. Find out the maximum and minimax. If it is not matching, there won't be a saddle point. And as I said, there is no saddle point in this case. Let us go ahead and solve the problem using the dominance theory or the principle of dominance. Okay, now looking at this particular chart, I won't be going ahead, but let me explain you here itself. Now, if you look at the first row, okay, not the first row, the first column. Let us look at the first column first. Or it's up to you whether if you want, you can go column wise or row wise. Now, by observation itself, you can see that if you look at the first row and compare it with the other rows, you'll find that now this values, you can say 4 is equal to 4, 3 is greater than 2, 1 is also greater than 0, 3 is greater than 2, 2 is greater than 1, and 2 is also greater than 1 here. So the second row is dominating the first row. Okay, so we should neglect the first row. So delete this first row. My new matrix will be having rows 2, 3, 4, and 5. Okay. Like this, you can compare the other columns as well. Now, once we remove this, then let us compare the other rows. Now, 3 is equal, 1 is less than 7. But here, this is less than 3, so I cannot do anything here. Let us go ahead, check 4 and 1. So you need to check 1. Check the row number 2 with 3, then 2 with 4, and 2 with 5. I think there's no change here. Let us check 3 and 4. So there's again this 7, 4, this -5 is less than, so we cannot do anything here. Compare 3 and 5. Again, 7 and 3, 7 is greater, but -5 is less than -2. So no changes here. Now let us compare 4 and 5. This is equal here. 4 is greater than 3. -1 is greater than -2. Great. This is equal. So here we can, I think row number 4 is dominating row number 5. So we need to ignore or neglect the row number 5. So finally what I'll get only 3 rows, 2, 3, and 4. Understood this? Now, once we complete with the rows, you can compare the columns. Now, in case of the columns, the one which is maximum has to be removed, right? So let us compare the first column with the second one. Now, this is all greater than these values here. Okay, so immediately I can remove this, the greater one. So the first column goes off. Okay. Now use the second column and compare with 3. This is greater, but here we have 7 greater than 3. So there's no change here. Compare 2 by 4. So here we have 2 is equal to 2, then 3 is equal to 3. This is less, this is less, this is less. Okay, so 2 can be ignored because all the values are either greater than equal to the values or the elements corresponding values of column number 4. So even 2 will go off. Okay. So we have now 3, 4, 5, and 6. Now compare 3 with 4. This is not going out. And 4 with 5. 2 is greater, 3 is greater, but this is less. So 4 with 6 also we can compare. 2 is greater, 3 is greater, but here we have a lesser value. So no need of changing anything. Now compare 5 and 6. Now this is equal here. 2 is greater here, 2 is equal. So 6 can be removed here. Okay. So finally I'll get row number 2, 3, 4 and columns 3, 4 and 5. Okay. Let us see the solution for this. Now this is what we did, and we removed the row number 1 and 5. Okay. I hope you have understood this. Then we removed the columns and we got this final 3 by 3 matrix. And we cannot reduce this just by comparing it. So we need to go for that ratio. Okay. So let us see whether we can combine the row number 2 and 3 with a ratio 1 by 2, 1 by 2. So the value of k we'll take as 1 by 2. And automatically I'll get 1 minus k as 1 by 2. Now, when we come next, we'll solve this problem further. Okay. We'll stop here today. Please go through this once again to understand it so that when we come next, we'll